So very good evening to all of you. I hope you all are doing great. And today in this series, my dear, we are going to start the applied thermodynamic. Just before starting the session, let me know is my audio video clear or not. And after that, we are going to start a very wonderful session for all the mechanical engineer. You just write in the comment section, is all good or not? Okay. So in this top 500 series, what exactly we are doing, 15 questions we are going to solve in this session, and other 15 questions I am going to give you, or all the faculty are going to give you these all 15 questions as a homework, my dear. Okay. So in the engineering thermodynamic, today topic is the applied thermodynamic. We'll be discussing power plant, steam turbine, compressor, IC engine, and refrigeration and air conditioning. These all topic will be covered in the today's session, my dear, in these 15 question of the live session and 15 question of homework. So let's start the session. You just write in the comment section and share with your friend, so that your number of friend can join the session and they can compete here with your friends. This is all about me. I have 10 years of experience in teaching field of GATE and ESE, Master in Thermal, my dear. This is all about the subject I am dealing with. So let's start the session, but before starting the session, let me share one important information for you guys. Maha Marathon is going to start from 3rd of January. In this, we are going to discuss each and every important formula of entire mechanical engineering and civil engineering branch. And definitely, my dear, you must join this session. And one more important information for all the mechanical and all the engineering students who are going to prepare for GATE 24. Dheeraj sir is going to conduct the mega workshop on the topic of a strategy to win top 1% for the GATE 24, my dear. Time will be 12:30 and date will be 1st of Jan. Okay. So you just write in the comment section is all fine or not, and after that I am going to put the first important question for you till the last session, my dear. Up to 3:30 we have already solved in the last session, and 3:30 to 3:45 I have just given you these all the questions as a homework. And after that, in this today's session, my dear, we are going to have the next 30 questions, 15 questions in this live session and other 15 questions as a homework. Yes, right, the correct answer of this question, in the reheating Brayton cycle, what is the exact answer, my dear? MSQ question is there, let me tell you. Reheating Brayton cycle, it will be somewhere like this, if I am not wrong. So it is 1 to 2 to 3 to 4, 5 and 6, my dear. This is the example of reheating Brayton cycle. MSQ question is there. You need to select TS diagram. You need to select what is the correct answer. Yes, write the correct answer of this question. Turbine work increase because pressure lines diverge. Compressor work increase, heat rate increase, or efficiency increase. Let me tell you in advance, my dear, that your heat rate is just a reciprocal of one of efficiency. Heat rate is the reciprocal of the efficiency. Okay. So now select the correct answer. MSQ question is there, my dear. MSQ. Turbine work increase, sir. If reheating is not there, then this is the area of the work done. The area of the DS diagram. So this is absolutely correct answer. Turbine work increase, Mohammed. Okay. What about the compressor work? It remain constant. Not a correct answer. What about efficiency? Efficiency decrease, my dear. Efficiency of the Brayton cycle decrease in reheating. So this is absolutely not the correct answer. So if the efficiency decrease, then definitely, my dear, heat rate will increase, because heat rate is the reciprocal of the efficiency. Answer A and C will be the correct answer of this question. Absolutely right. Good. Solve the next question. It's not MSQ. Very good evening, Kiran. Mohammed, very good evening. You just write the correct answer. Like and share the session with your friend, so that maximum number of your friend can join and you can have the healthy competition in the session, my dear. Yes. Select the correct statement. Maximum temperature in the gas power plant is higher than that of the steam power plant. Maximum temperature of the gas power plant is higher than that of the IC engine, maximum temperature in the gas power plant is lower than the steam power plant, or the maximum temperature in the steam power plant is higher than that of the IC engine. Yes, select the correct answer. Sir, here let me tell you, this is the temperature of the steam power plant. Very good, serious. This is the temperature of gas power plant. This is the temperature of IC engine. Now in these all the portion, my dear, you have to maintain the relation. Temperature of IC engine, temperature of gas power plant, temperature of steam power plant. Let me make the correct sequence, my dear. Maximum temperature of the IC engine, you generally have 2500 to 3000. Maximum temperature of the gas power plant near about 1200, and maximum temperature of the steam power plant is near about 650. So you can have the sequence like this. Maximum temperature in the IC engine is maximum, then gas power plant, and after that, my dear, your steam power plant. This is the answer. So let's check. Maximum temperature in the gas power plant is higher than steam power plant. Absolutely right. Maximum temperature in the gas power plant is higher than IC engine. Absolutely wrong. Maximum temperature in the gas power plant is lower than. Absolutely wrong. Maximum temperature in the steam power plant is absolutely wrong. A is only the correct answer. Serious. D is not a correct answer. You are not having more than 6 or 700 degrees centigrade in steam power plant, and in IC engine generally you are having more than 2000 degrees centigrade temperature. Okay, good, very well played, my dear. A is the correct answer. MCQ question is there. After that, let's see the next question. Yes, question number 348. Kiran, a single acting two-stage air compressor. Let me tell you, my dear, these all questions we are dealing with up to question number 253. We are dealing with 1 marks question. Okay, yes. So a single acting two-stage air compressor deal with 4 meter cube per minute of air at a pressure of 1 bar, temperature of 5 degrees centigrade with a speed of this RPM, my dear. Delivery pressure is the 100 bar. Then what if the intercooling is complete, perfect intercooling is there, then what is the intermediate temperature after first stage or before the second stage? So if we draw either PV diagram or TS diagram, my dear, then PV diagram will be somewhere like this. 1 to 2 is the first stage. After that, my dear, perfect intercooling. And after that, 3 to 4, my dear, it's a second stage. So here, this is the pressure P1, this is the pressure P2, and this is the pressure P3, my dear. If there is a perfect intercooling, then P2 is equal to P initial and P final. Someone of you are writing lock it. Very good. Good. This confidence I want. Only 2 of you have just given me the right answer. P1, my dear, 1 bar, and P3 final is 100. So answer will be equal to 10 bar is the correct answer. Absolutely right. Yes, 10 bar is absolutely right. Let's move forward. Yes, important question is there, my dear. In cascade refrigeration system, very important question. Even the question is 1 marks question, but yes, it is the important question for 1 marks, my dear. In a cascade refrigeration system, COP of upper refrigeration cycle. You must know cascade system means 2 refrigerators are connected in series. Okay. So COP of upper refrigeration cycle is 3. COP of lower refrigeration cycle is 4. Total power required to produce 1 kilowatt refrigerating effect is, my dear. Write the answer very correctly. Okay. Kiran, you write B answer. Shreyas, you write B answer. Deepak, what do you say? And Mohammed, where are you? What do you say, Javir? Mohammed Javir, I've discussed this question in the classroom also. Not exactly with the same value. Yes, Manas, very nice. Good. Sir, COP of the cascade refrigeration system, we always write COP of 1 multiply by COP of 2, my dear, and divided by COP of 1 plus of COP of 2 plus of 1, my dear. In this case, we can write 4 into 3 divided by 4 plus 3 plus of 1, my dear. Answer will be equal to answer will be equal to 12 by 8. This answer will be equal to 3 by 2 or 1.5, and in this case the overall COP can be written by refrigerating effect divided by power input. Yes, power input is 1, power input is I need to calculate what is the power input when refrigerating effect is 1 kilowatt divided by 3 by 2, my dear. 1.5 means that is 2 by 3. Answer is 0.667. Sir, let me tell you, I'll be more happy if any one of you write directly what is the numerical value of the overall efficiency in the same way when refrigerator is replaced by Cascade heat engine, my dear. Are you able to know this point? And this overall efficiency is written like this. All of you, my dear. Everyone. Or if you are not taking the 100, then answer will become in 0.0 something. Are you aware with this formula? Overall efficiency whenever you are using the 2 heat engine in place of refrigerator, something like this. Okay. Kiran, what is the bottom cycle and my dear, what is the top cycle? Let me tell you what is the meaning of it. When you are dealing with the Cascade refrigeration system now, then my dear, in this one you are using actually 2 refrigerators. Because in simple refrigerator, what exactly we are doing? We are just taking some heat from the lower temperature body and we are rejecting the heat to the atmosphere. This is the simple refrigerator. But what exactly you do in the Cascade refrigerator system, you place 2 refrigerators. Right now, first of all, from one refrigerator, you are taking the heat from lower temperature body. But to the higher temperature body, right now it's not a environment. Right now it's a second refrigerator. So condenser of the lower refrigerator is connected with the evaporator of the upper refrigerator. So first of all, heat is taken in the series, my dear. In this case, first of all, heat is taken from the lower temperature body to the refrigerant, which is moving in the upper refrigerating cycle, my dear. Can we write like this? Good. Right. Correct. No. मानस ऐसा कोई फॉर्मूला बनेगा नहीं, अदरवाइज यू विल बी इन ट्रबल. मतलब एग्जैक्टली ऐसा फॉर्मूला नहीं है कि आप n1 से कनेक्ट कर दो कि आफ्टर दैट 3 मेंबर आर देयर, देन n1 plus n2 plus n3 will be somewhere like this. Okay, yeah, these are the industrial refrigerator. These are generally used, let me tell you in advance, these are generally used when we are dealing with the cryogenic refrigeration system. When you are dealing with the temperature lower than -100, -180, -170, then in that condition, my dear, temperature difference between the atmosphere and the lower temperature body is so much high. So when you will deal with this single refrigerator now, then compressor has to do a lot of work that is near to impossible, because the difference of the temperature is very much high. Means you are just taking the heat from -100 degrees centigrade and you want to reject this heat to the 35 degrees centigrade. It's quite difficult. Temperature difference is near about 135 degrees centigrade. So in the compressor, it is very difficult to achieve this temperature difference, my dear. Right now, that's why we are using such a refrigerant, that or the refrigerator which can take or which can fulfill the requirement in 2, 3, 4 cycle, my dear. Okay, yeah. Sir, I saw that for efficiency. No. Efficiency formula, whatever you have seen now in second law of thermodynamics, my dear. Let me tell you, in this case, the second law of thermodynamics, we write W divided by heat supply, my dear, 1 minus T2 divided by T1. This is the formula. This formula you write, and let me tell you, this second law efficiency formula is the actual formula, my dear, divided by efficiency of Carnot cycle. Okay, this one. This is the second law efficiency. So this formula you have definitely seen when you are dealing with the second law of thermodynamics or second law efficiency, my dear. Clear? Yeah. And yes, this topic I have already taught you in second law of thermodynamics or Clausius inequality law. So definitely in that portion you have also seen the same topic. Anyway, let's move forward. There are a lot of questions yet to come. MCQ question is not there. MSQ question is there, my dear. You can select more than one answer in this case. Yes, write the correct answer. Deepak, Manas, write down the correct answer. The list 1 and list 2 is given to us. Which of the following is or are correctly matched, my dear? NH3 is given, CCl2, F2 is given, CHCl, F2 is given, or somewhere like this. Yes, What is the correct answer you all guys getting, my dear? Let's see how many of you are getting the correct answer. देखते हैं. If you really want to score well, then every time you must be prepared for the practice and only practice related to the question. Because for next 20-30 days, my dear, you need to do only 3 activities. 1, rewrite all the formula as much as possible. Second, rewrite, don't read the formula. Rewrite all the formula as much as possible. Second, try to solve the question as much as you can. And third, my dear, write more and more test series. Yes. Kiran Kumar, you want to say? No. It's not the matching. This is clearly written, my dear. You need to select the answer, I mean A, B, C or D, which are correctly matched. You need to select the answer which are correctly matched in this option, my dear. This is the option. Means A, B, C, D, 4 options are given to us and correctly matched are also given to us. You need to select A is correctly matched, B is correctly matched, C or D, like this. Right now, I think Mohammed and Kiran, you have got the point. 1 and 4 according to you. Very nice. Okay. Very nice. Sir, first of all, you must know that A is absolutely the correct answer because ammonia is the non or inorganic compound. It is starting with 7 followed by the molecular weight. Absolutely right. After that, my dear, 1. Carbon component must be 2, my dear. Absolutely wrong. Because if in the starting it's 1 now, then carbon component will be 2, my dear. Absolutely wrong. Let's come to the C, my dear. 0, 2. Okay. Hydrogen and fluorine 2, my dear. Is it the right answer? C, 1. Absolutely right. After that, hydrogen 1, my dear. Good. After that, fluorine 2, my dear. Absolutely. This is also the right answer now. AC is the right answer. Is it or not? It is the right answer. D is absolutely wrong answer. Why, sir? R12, you will write R012. 0 means carbon 1. 1 means hydrogen 0. That is not possible. And my dear, 2 means F2. Yes, exactly. Yes. Absolutely right answer. A and C will be the correct answer, Manas. Your answer correct. Kiran, your answer is not correct. Ranjit, your answer is a little bit wrong. Mohammed, your answer is also wrong. Are you getting the correct answer, my dear? A and C will be the correct answer. If you are having any doubt, feel free to ask. A and C only the correct answer. दो ही आंसर इसमें सही है, A and C. If you are having the confusion between B and D, feel free to ask. I am here to give you the complete explanation. If you are not okay, yes. R12 is CFCl3. Exactly. R12, my dear. R12 is CFCl3. Tetra chloro monofluoro methane. Yes. And this monochloro difluoro ethane, my dear. That is the reason this component and this component both are known as CFC. Okay. Good. AC is the correct answer. Anyway, let me tell you the final answer. A and C will be the correct answer. Absolutely right. Let's go for the next question. The ratio, very important question, only for 1 marks, my dear. 1 marks question is there, but important question for you all guys. Yes, the ratio of the clearance volume to the displaced volume, like swept volume is given, clearance volume is given, and ratio is given. Specific volume at the inlet and outlet of the compressor is 0.04 and 0.02. Volumetric efficiency of the compressor. Lot of time it will confuse you. Lot of time कई सारे क्वेश्चन माइंड में आएंगे, but if you are having the full command over the formulas, then you are not going to feel any problem to solve this question. Yes, please. Let's see how many of you are getting the answer of this question, my dear. Because when you start to solve the question like this now, then definitely you are just going to score after 60, after 50, because up to 40-50 marks, my dear, whatever question we have discussed for 1 marks, you can see the question like this. These are the questions which can make the difference. Write the correct answer of this question. Let's see how many of you are getting the correct answer of this question, my dear. Yes, I'm waiting for the correct answer. Kiran, Deepak, Manas, everyone. A is the correct answer according to Sirius. Very good. Very nice. Wonderful. Anyone else? Manas, Kiran, very good. Sir, we know the efficiency of the volumetric efficiency, it is written by 1 divided by volumetric or the clearance ratio. My dear, P2 by P1 raised to 1 by N minus of 1. Is it clear to all? ये फिर से उत्कर्ष आया है, मुझे पता है उत्कर्ष. Okay. P1 V1 raised to N is equal to P2 V2 raised to N, or my dear P2 by P1 raised to N 1 by N can be written by V1 by V2. It is already clearly mentioned in the question. So in this case, if you want to write the volumetric efficiency, it can be written by 1 minus how much? Clearance volume 0.05. Very nice. And V1 by V2, V1 0.04, V2 0.02 minus of 1 is the correct answer. 95, my dear. Absolutely right. Only 5 or 6 people of you have written the correct answer. Yes. If you want to solve, then definitely you need to solve this type of question. Next. Question number 52. MSQ question is there, my dear. Power plant MSQ question is there. Consider the following statement from the MSQ. Nozzle, turbine, all the things are given here. Let's see how many of you are getting the correct answer. If you really want to score well in the GATE exam, you need to prepare for everything. MSQ, MCQ, NAT, all the type of question at the same place, my dear. Yes. It's not like this कि आसान question कर लिया और फिर हो जाएंगे. It's not like this. We have written the test last night. That is the reason we are not going to write tonight. Every night you have to fight for the rank. नहीं तो याद रखना, जब आप सो रहे होगे तो इस इंडिया में कोई ना कोई किसी कोने में बैठा हुआ आपकी सीट के लिए लड़ जरूर रहा होगा. MSQ question is there, my dear. It's not a MCQ. Yes. Consider the following statement. Select the correct answer. Yes. Select the correct one, my dear. A is the answer. Very good. C is the answer according to Deepak. Maybe the correct answer, my dear. Anyone else? Sir, D-level turbine or nozzle is the subsonic nozzle that is used in turbine. Supersonic nozzle is the diverging cross-section area, my dear. Supersonic nozzle, let me tell you, supersonic nozzle is the diverging cross-section area. Absolutely right. Subsonic nozzle you have shown or you have seen number of time, my dear. This is the example of subsonic nozzle like this. Okay. So this one is the nozzle whatever we see, my dear. This is the subsonic nozzle. Okay. Subsonic, and this one is the supersonic nozzle. So supersonic nozzle is the diverging cross section area. It's absolutely right, my dear. And subsonic diffuser is the diverging cross section area. It is absolutely right also. This diverging cross section area in subsonic flow, my dear, subsonic flow, it behaves like a diffuser. But in supersonic flow, my dear, it behaves like a nozzle. When you start from 1 to 2, my dear. Yes. Ashish, very good evening. Kaise ho, Ashish? So this is also the correct answer. Curtis turbine is the example of pressure compounding turbine. Absolutely not. Very good, Kiran. Absolutely not. Curtis turbine is the best example of the bellows compounding, my dear. You just decrease the velocity in a very slow manner in the case of Curtis turbine. So is the correct answer, B is the correct answer, C is the correct answer. ABC will be the correct answer. D is absolutely wrong answer in this case. किसी ने कुछ select ही नहीं किया. Very good. बहुत सही आशीष. Let's solve this question. 2 marks, but easy level of question is there. Time will matter a lot in this case, my dear. I am very fine. बहुत अच्छा हूं, इसीलिए मैं लेक्चर ले पा रहा हूं. I hope you are doing great. चलिए, in the diesel cycle start with the calculator. अब यहां से आपका कैलकुलेटर का स्टार्ट हो गया है काम, और देखते हैं कितने लोग आंसर इसका करेक्टली ला पाएंगे. The cutoff ratio take place at the 5% of the stroke of the piston. Compression ratio of the diesel engine is 12. Cp, Cv and gamma is given. What will be the overall efficiency of the cycle, my dear? Let's see how many of you are getting the correct answer in this case. थोड़ा आंसर जाग के लिखो, just like the session यार एक बार. There are total number of 30 question, my dear, there in this session. Very good. D is the answer according to diesel cycle is there, my dear. I am fine, Ashish. पहले आंसर तो लिखो एक दो. I am waiting for the correct answer from your side. Yes, very nice. Wonderful. Wonderful. Cutoff. Cutoff means this one, my dear. And a shortcut formula I have told you number of time that cutoff ratio is always written by C, at which percentage cutoff take place, divided by 100, my dear, into 1 plus into R minus of 1. This formula I have told you number of time, where R is the compression ratio. What is the compression ratio in this case? 1 plus what is C? C is 5 divided by 100, my dear, and this is R 11. What is the answer? Can you please tell me what will be the answer of this case? Is it, are you getting 6.6? Is it something wrong or is everything fine? 5 divided by 100. Yes, absolutely right. 1155.55. Yes, it is 1.55 if I'm not wrong. Yes or no? It is 1.55. Is it? Yes. Then overall efficiency can be given by 1 minus of R raised to 1 upon R raised to gamma minus 1 into rho raised to gamma minus 1 divided by gamma into rho minus 1. When I substitute all the values, my dear, we are getting 1 divided by R is 12 raised to 0.4, because gamma is equal to 1.4. How much rho? 1.55 into gamma 1.4 minus 1 divided by 1.4 into 0.55. Whenever you will calculate the answer, you definitely get D as a Delhi is the correct answer. So 17-18 people of you are here, but you are writing only 5 or 6 of you are writing the correct answer. बाकी सब लोग क्या कर रहे हो? याद रखना, अगर यहाँ पे देखोगे तो एग्जाम में देखते रह जाओगे. अगर अभी हंसी मस्ती में आपने टाइम निकाल दिया तो एक बात याद रखना, आपके एग्जाम ऐसे मजे लेगा कि 23 वाला सपना 24 में चला जाएगा. एंड आफ्टर दैट यू विल से ओनली वन थिंग, वो अफसाना जिसे अंजाम तक लाना ना हो मुमकिन, उसे एक खूबसूरत मोड़ देकर छोड़ना अच्छा. ऐसा मत करना. Fight till the last date of the exam like a warrior. Yes. Question number 354. Consider the following statement. Okay. Yes, Kalyan. No. Everything I am going to discuss, but somewhere there is something line or the proverb I generally use in the. Otherwise, all the technical thing, don't worry. Right now I am using each and everything in English. You need not to worry. Yes. Because Kalyan, this is not for you, because you are very serious in the class. You need not to worry about this. This is only for the guys who are not so much serious in the class. So इसलिए आपको समझने की, that's why you need not to understand this. Come back to the point. Yes, write the correct answer, sir. It is the best example of the Electrolux refrigerator. Let me tell you, in the Electrolux refrigerator, there are number of important point, whatever I have discussed with you, my dear. Write the correct answer. MSQ question is there. Let me tell you in advance. MSQ. It is the refrigerator without pump or compressor. It is the refrigerator having the three working medium. The refrigerator in which hydrogen work as the refrigerant. The refrigerator in which water work as the absorber, my dear. Very good, Kiran. Very nice, wonderful. Kalyan, I am waiting for the answer. A, B, D will be the 360. I think you are. A, B, D will be the correct answer. Yes, sir. This is the refrigerator or the example of the BAR system, vapor absorption refrigeration system, in which we are not using the compressor, my dear. We are not using the pump. This is the refrigerator in which there is no reciprocating device, my dear, we are using. That's why this is the refrigerator without compressor and pump. Yes, absolutely right. Second, it is the refrigerator which is utilizing three working fluid. One is the ammonia, my dear, someone of you have written. Second is the water, my dear, and third one is the hydrogen. Okay, not sodium, hydrogen, my dear. Right? Kiran, it's not a sodium. Yes. Okay, good. Very nice. Refrigerator in which hydrogen work as a refrigerant, absolutely not. 200% not. In this refrigerator, my dear, ammonia is used as a refrigerant, water is used as an absorber, and hydrogen is used to reduce the partial pressure of ammonia in the evaporator, so that by decreasing the partial pressure, freezing temperature of the ammonia as a refrigerant also decrease in the evaporator and heat transfer rate increase, my dear. So it works just like a catalyst, thermal catalyst, which increase the thermal energy rate, absorbing of the thermal energy rate, and after that last one, water work as a absorbent or absorber is absolutely right. A, B and D will be the correct answer. Now you must ask this question, sir. Generally this question is asked in the interview also. If you are not using any working device, moving device, then what or how the flow of the working medium is possible? Then answer is your gas phase move upward due to the density difference and your liquid phase move downward due to the gravity effect. Okay, this is the complete reason of the flow of this working medium, my dear, or the refrigerant. Let's move forward. Yes, I am waiting for this question, my dear. If 10% of you are able to write the answer of this question, then definitely you have studied a lot of thing in thermal. अगर आप में से 10% भी इसका आंसर दे पाओगे, 10% only. If 2 or 3, 10% means, then definitely you have studied a lot of things in the Otto cycle, my dear, or the IC engine. For the simplicity, let me draw the Otto cycle, my dear, for you. This is PV diagram, right? 1, 2, 3, 4, like this. Like this. This is the cycle. Kiran, I am waiting for the correct answer. Deepak. Yes, Kalyan. Write the correct answer. The efficiency of the Otto cycle is, my dear, 40%. Change in the pressure during the heat supply process is 7 bar. Compression ratio is 4. Then what will be the mean effective pressure of the cycle? Kiran, you say 2.8 bar is the correct answer. Very nice. Kalyan, you say D is the correct answer. 6.25, my dear. It's not possible. Let me tell you why it is not possible. Because maximum temperature of the cycle is 7. So mean temperature is somewhere in between of this minimum and maximum temperature. So nearby 7 answer is not possible. Yeah. So let's see the answer, my dear. The mean effective temperature, if you are aware with this formula, it is okay. Mean effective pressure is given by, yes, very good, very good. Sir, if you don't know the answer of any question, उसको हर चीज को दिल पे नहीं लेना है. You have to make the habit from the starting that if question is not clear to us, then directly we are going to skip that question for the next round of the sequence. Like this will be given by efficiency of the Otto cycle multiply by change of pressure of the Otto cycle divided by, my dear, gamma minus of 1 into R minus 1. If you are aware with this formula, you can solve. Otherwise, you are not able to solve this formula. 0.4 multiply by, how much is the compression ratio? 3. So when you will solve this answer, my dear, you will get the correct answer of this question. So this is 48 into 7 divided by 30 into 4 or 3 into 40. That will cancel by 12 times. That will cancel by 10, and this one is how much? 4 times. Answer is 2.8 bar. Very nice. Absolutely right. It means you have studied everything in very detail. Very good. Nice. Next. The velocity of the steam turbine at the nozzle outlet of the turbine is 400 meter per second. Blade operate on the maximum efficiency. If the nozzle angle is 20 degree, alpha is 20 degree, then the steam flow rate is this one, my dear. Then considering the equiangular blade angle and the blade friction negligible, and neglect the blade friction, the blade power will be, yes. Let's see how many of you are getting the correct answer of this question. Blade power you need to calculate in this case, my dear. It's a question of the impulse turbine. Let me tell you clearly, because the nozzle angle is directly given to us. Velocity of the steam at the inlet of the outlet of the nozzle is given to us. It means kinetic energy is indirectly given to us. Then let's see how many of you are getting the correct answer for this question, my dear. Serious for this, B for Bombay is the correct answer. I mean question number 356, you are getting B for Bombay is the correct answer, or for previous question, because B was the answer of the last question also. So have you given the answer for this 356? Is it? Okay, previous question. Write the answer of this question. There is the one steam turbine. Very good. D and again a question mark. Not like this, Kiran. Either it will be D or it will be, okay, D is the answer according to Kalyan. Very good. Good. Sir, if the impulse turbine is, okay, let's take your time. Try to solve first. Sir, if the impulse turbine is working with the maximum efficiency, then, my dear, maximum efficiency formula or diagram efficiency formula is written by cos square alpha. Is it or not? Then how much cos square alpha, my dear? That is cos square 20. Can you please tell me what is the maximum efficiency of this turbine, my dear? Can you please tell me what is the maximum efficiency of this turbine, my dear? Cos 20 is the answer, and answer into answer is 88.33. Am I right? Good. And what is this maximum efficiency we write, my dear? Maximum efficiency is power output divided by, my dear, kinetic energy. Is it or not? Or power or the blade power. It can be written as the maximum efficiency is 0.883 into kinetic energy 1 by 2 mass. How much mass is there? 0.6 into velocity square, that is 400 square. What is the correct answer you all guys getting? Can you please tell me the answer? Into 1 by 2 multiply by 0.6 multiply by 400 square. Answer is 42.38. This is the answer. Are you not getting this answer? Is it? Kiran, Kalyan, are you not getting B for Bombay answer, my dear? B for Bombay is the correct answer. Are you not getting? Yes. B for Bombay is the correct answer of this question. Good. Next. One of the easiest question for the IC engine, my dear. IC engine का सबसे आसान क्वेश्चन में से एक. In a more test of the 4-stroke IC engine, following observation are there. Following data is there, my dear. When all cylinders are working, then brake power is 2000. First cylinder is cut off, brake power is 1500. Second is cut off 1100. Third is cut off 1200. And fourth cylinder is cut off, then the power is 1400. What is the mechanical efficiency of this IC engine? What is the mechanical efficiency of this IC engine, my dear? Arey wow, very nice. 71.42% is the answer. इतना जल्दी आंसर आ गया. Wonderful. Great. First of all, you need to know what is the IP of the first engine. IP of the first engine, brake power when all are working and brake power when one is cut off, my dear. What is the brake power when all are working, my dear? That is 2000 minus of 1500. Answer is how much? 500. What is the IP similarly of second one? 2000 minus 1100, 900 kilojoule. What is the IP of third one, my dear? That is 800 kilojoule. And what is the IP of fourth one? That will be equal to, my dear, 600 kilojoule. What is the total IP? Total IP from here can be written by 600, 800, 1400, 1400 and this 900 will be 2300 and 500 it will be 2800. Is it or not? Yes. So this is the IP, my dear. Can we write that overall efficiency will be equal to 2000 brake power divided by IP 2800. Answer will be equal to 20 by 28 into 100. What answer we are getting? 71.4 is the correct answer. Absolutely right answer. Yes, Kalyan. Now you have written the absolutely right answer. Ab sahi likha. Good. Question number 358, my dear. Question is related to the most air, or simply you can say the question is related to the this psychrometric topic. The steam of the most air whose mass flow rate is 20 kg per second with the humidity ratio of this one is entering into a stream like this. Like this. A mass is entering in this case and a steam is entering from here. With the second steam of the most air, my dear, mass flow rate is this one, humidity ratio is this one. Then assume the proper mixing. What is the humidity ratio? So one mass is coming from here, second mass is coming from here. Then what is the third mass? This is the question, my dear. Can you please tell me the answer? In this case, how much correct answer you all guys getting, my dear? Let's see. Dry air is given to us. A is the correct answer according to gram per kg of the dry air is asked, my dear. Gram per kg of the dry air is asked. Yes. 20 kg with the humidity of this is coming, my dear. 13.33 is the answer according to Kiran. Anyone else? Kiran is getting 13. Sir, can we write total mass of M1 plus of total mass of M2 is equal to total mass of M3. If I want to write, this total mass will be equal to dry air mass plus of W1 into dry air mass. Similarly, can we write dry air mass plus of W2 into dry air mass like this. Similarly, what will be this one? M3. How much will be the M3? 20 and plus 10, my dear, it will be 30 plus of W3 30, my dear. Is it? So if I'll take MA1 common, that will be equal to 1 plus W1. If I'll take MA2 as a common, that will be equal to 1 plus W2, that will be equal to 30 into 1 plus W3. Everything is given in the question. W1, W2, MA1, MA2 is given in the question. You will substitute all the value, my dear, and you will easily get the answer of each question. What is MA1? Sir, 20 kg. Is it given clearly? It is given or not? Yes. What is 1 plus W1? 0.01 plus MA2 10, my dear. W2 0.02 is equal to 30, 1 plus of W2. So you will get the answer in kg per kg of the dry air. You will convert into the gram per kg of the dry air. You will absolutely write A is the Ahmedabad correct answer for you, my dear. Kiran, serious? Kalyan, have you got the same answer? When you will solve this, you will get the answer in kg per kg of the dry air. And when you replace, my dear, you will get the correct answer for this question. All of you are getting the correct answer? Good, good, good. Very good. 13 is the correct answer for you. Let's move forward. Question number 59, my dear. 60 question, 60 question we are going to discuss in this session. And other 15 questions I am going to give you as a homework. Let's see how many of you will solve these out of 50 questions. Sir, question is related to the BCR cycle. In this case, a refrigerator working on ideal vapor compression cycle operate between the temperature limits of minus and 40. The refrigerant enter the condenser as a saturated vapor and leave the saturated liquid. Sir, it is clearly mentioned in this question, your refrigerant is entering into the condenser. If I'll draw the TS and pH diagram, my dear, then your refrigerant is entering at a saturated liquid and leaving, entering at a saturated vapor and leaving at a saturated liquid, my dear. After that, 2 to 3, it will be the somewhere like this, 3 to 4, 4 to 1, like this. Similarly, if I'll draw the pH diagram, very nice, wonderful. This 1 to 2 to 3 to 4. First of all, you need to see what formula you need to apply. I need to find refrigeration effect, my dear. RE I need to find, RE. Can we write RE will be equal to mass flow rate into H1 minus of H4. Sir, H1 is this one, H4 is equal to H3. H3 means at higher temperature, what is the value of this? HF. Can I write this? H4 is given to us 80 kilojoule, if you don't mind. Is it or not? Yes. Mass flow rate is given to us how much? 0.025, my dear. Can we find what is the value of H1? But for the H1, you need to find dryness fraction. Any one of you can tell me, my dear, what is the numerical value of the dryness fraction? What is the numerical value of the dryness fraction? X. Because in this question, it is clearly mentioned that S2 will be equal to S1, my dear, where the value of S2 will be equal to S2 entropy at the higher temperature, thus 0.67. S1 will be equal to F plus of X Sg minus F. So in this case, we are getting X is equal to 0.9. Can you please tell me what is the value of H1? That is equal to HF1 plus of X Hg1 minus of HF1. Can you write the value of H1 from here? What answer you all guys getting, my dear? Manas, it is 164. More than 80. It is 164 kilojoule per kg. Yes. After that, your refrigerating effect will be equal to 0.025 multiplied by what is the value of H1, that is 164 minus H480. Whatever answer you will get, that will be the kilowatt is the answer. Are you getting? 2.1 my dear. All of you getting 2.1 is the correct answer. Yes, very nice, wonderful. This is absolutely right answer. After that, this is the question. After that, I'll give you the 15 more question as a homework. Find the required air fuel ratio in the gas turbine whose turbine and compressor efficiency is 85 and 80% respectively. Maximum cycle temperature is given 875. Working fluid can be taken as air. Cp and gamma is given to me, which enter the compressor at this pressure and temperature. Pressure ratio is given to us. Fuel used has the calorific value. Has calorific value of 42,000. Then there is a loss of 10% of the calorific value. Then what is the percentage ratio, my dear? Sir, very carefully you need to check the answer. If it is the combustion ratio or the combustion chamber like this, my dear, then fuel is entering at a temperature of, air is entering at a temperature of T2 dash and fuel is entering with this calorific value, that is mixing. From here MF plus of MA is leaving at a temperature of T3, if you don't mind. So can be right, my dear. H per the energy balance equation, mass of the air Cp into T2 dash plus of calorific value MF into Cv. If 10% is lost, then 90% will be the efficiency, will be equal to Ma plus of Mf into Cv into T3, my dear. If I'll divide the entire equation from fuel, I'll get Cp into T2 dash plus of this is mass of air divided by mass of fuel. This is Cv into 0.9 will be equal to mass of air divided by mass of fuel plus of 1 into Cp into T3, my dear. Now, if you are able to find the value of T2 dash, then each and everything given in the question, because T3 is the maximum value that is given to us, 875 degrees centigrade. Combustion ratio is given to us, calorific value is given to us. By solving this, are you getting A4 Ahmedabad is the right answer? That answer is 55.13 will be the correct answer of this question, my dear. How many of you are getting, or can you please tell me what is the value of T2 dash? Kiran, what is the value of T2 dash in Kelvin, my dear? Because T2 you will calculate from T1 and pressure ratio. T1 is given to us, that is 300. It is clearly given to us that T1 is equal to 300. Can you directly tell me the value of T2 dash? 482.25? Absolutely right. When you will substitute 482.25, you will get the correct answer, that is 55.15 is absolutely right answer. Very good, Sirius. Very nice. Good. So maximum question you all guys have solved. No, it's Kiran, it's T2, not T2 dash. 445 is the value of T2, not T2 dash. Yes, exactly. Good. A is the correct answer. You have got, my dear. Let's move forward. Let me give you some question as a homework. Question number 61, 2, 3, 4, 5, 6, 7, 8, 9 and 70, 71, 72, 73, 74, 75. These 15 questions, my dear, are again for the homework. Generally, these questions I have just given you a little bit easy question, whatever you have solved. 1 or 2 questions are the challenging question in this. One of them question is this one, my dear. Try to solve all these questions and answer you can share on my Telegram channel, that is the Mechanical by Sonu Chauhan. So this is the session I have just discussed with the basic as well as applied thermodynamic, my dear. See you again in the next session. So thank you all. If you are having any doubt, feel free to contact me either on the Telegram channel or personally, my dear. But again, for next 30 days, don't stop. अपने आप को रोको मत, लगे रहो इसी तरह से and definitely will win. Thank you all. Take care. Bye bye. If you like the session, just like the session. If you have enjoyed the session, my dear, like the session. See you again in the next session. Thank you all. Bye bye. Take care. Good night all. Good night.